Hello and welcome to the 1895 podcast with me, Tom. Now, unable to be joined today by my usual co-host, Rob. He's unable to make it into a studio today, but delighted to say I've got a very fitting replacement here with me. And that's in the shape of Mike Strobel, who's the Director of Engineering Services at Swagelok. Now, we've had Swagelok on this podcast a number of times, and it's always great to get into those conversations. And today, really interesting topic we're going to get into is gas distribution done right. But before we get into that, Mike, thanks for joining me today on the 1895 podcast. Great to have you on. Instead of me reading chapter and verse about you and a bit about your career, perhaps you'd like to introduce yourself and where your expertise lay in this area.
Sure. Thanks, Tom. Appreciate you having me on today. As you mentioned, my name is Mike Strobel. I'm the Executive Director of Engineering Services for Swagelok New York City, New Jersey, Philadelphia, the Middle East, and North Africa. I've been with Swagelok for about 13 years. I've held a variety of roles, including on the sales side as account manager. Then I transitioned into a field engineering role, did that for a few years before moving on to Swagelok Corporate as a field engineering supervisor for the Americas. After a couple years of doing that, I became the business development manager for the Americas for Swagelok Corporate. And in January of 2024, so about 2.5 years ago, I took this position as Executive Director of Engineering Services.
Fantastic. Great introduction there, Mike. And as I said, great to have you on. Now, over the course of this conversation, I want to get into some discussion around, the fundamentals of gas distribution system design, the common challenges that organizations might face, and the steps that operators can take as well to improve their system reliability and performance, all topics which are vital to this industry at the moment. But first off, for listeners who might not work with systems such as this every day, how would you exactly explain what a gas distribution system is and effectively why it matters to the overall facility performance?
Yeah, absolutely. I'd say a gas distribution system, it's a network of tubes, pipes, valves, regulators, any other components required that transport gas from a source to a point of use. And the source is typically high pressure, point of use is a much lower pressure and is the pressure required at that location. Very simplistically, you can say a gas distribution system moves gas from point A to point B. And it's critical because in facilities today, you need that gas to be available at the desired location 100% of the time. And it needs to get there at the required pressure and flow to optimize the processes, the experiments, the equipment that is utilizing that gas.
Great, thanks for that, and a great introduction to this topic that we're going to get into. So, gas distribution shows up across very different environments, from laboratories and research facilities all the way to power, clean energy, semiconductor, medical, various gas companies, so much more that I could go on with. So are there any common challenges that you see across all of these markets?
Yeah, absolutely. Challenges we typically see show up as variations in that pressure and flow that I mentioned, and even down to the very simplistic availability of the gas. Is the gas always where it needs to be? And we see that oftentimes it isn't. What we see out in the field are typically regulators that are undersized. Regulators are probably the most critical component in any gas distribution system. If they're undersized, not enough gas can reach each point of use location. So the folks that are looking for that gas can't get enough of it, right? So the processes suffer. Experiments could be completely ruined because there's not enough gas to complete that experiment. In reactors, if it doesn't get enough of that gas, the reactions either slow down or don't happen at all, and then you have to scrap that batch or perhaps do a bunch of rework. If the gas is feeding an analyzer, your analytical readings are no longer valid because they can't be trusted with that lack of gas. In semiconductor environments, you need the environment to be very specific with the gas mixes. And if you're not getting enough of one type of gas, you could have to scrap the entire wafer, a bunch of chips, which obviously gets very expensive. In addition, regulators that are of poor quality, they can't properly control the pressure. This becomes a safety risk. You may see an increase in pressure downstream. Anytime you have more pressure than you need, that poses a safety risk to the operator. And you run into a lot of the same issues that I just described when the regulators are undersized for flow, when you're talking about pressure as well.
Sure. So when you're talking to organizations who are planning or evaluating a gas distribution system, what do you highlight as the most important design decisions to overcome common challenges such as that? And when should they make those decisions as well? Presumably early on before the equipment is specified or installed?
100%, Tom. You want to make those decisions as early as possible in order to have functioning systems once you actually get to the installation. One important thing that I really haven't discussed yet is understanding any local regulations. Oftentimes, where you store the high pressure gas, there may be local regulations around that. Can you have high pressure gas inside, or does it all have to be stored outside? These are important things to consider. Are there any pressure limitations in the municipality or the area where you're looking to implement these gas distribution systems? Another really important thing to consider early on in the design phase is safe venting locations. Nothing's worse than putting in a brand new gas distribution system and everything looks beautiful, and then it's time to safely vent off and connect all the vents together, and they don't know how to do it. The customer has no idea how to actually do that. So how everything is going to tie together from a vent perspective is really critical. Is there any equipment necessary to scrub any dangerous gases before you can emit it to the atmosphere or send it to wherever you need to send it? And then finally, I talked about this a couple times. Early on, you need to know that flow demand. So taking into consideration all the processes, all the equipment, all of the experiments that are going to require flow, bringing that all together to know the full flow demand will help you adequately design your gas distribution system.
Sure, thank you for that, Mike. Now, gas distribution systems are becoming more and more complex, as we're seeing, which raises challenges by itself. But what engineering principles have the greatest impact on that system performance? You touched on it there, safety, but reliability as well. All of this from source all the way right to point of use.
I'd like to highlight three here: redundancy, maintainability, and material selection. Redundancy comes back to that availability of the gas, making sure that you have gas available to the end users 100% of the time, ensuring that it's at the right pressure, temperature, always there for the end user. Maintainability, a brand new system is wonderful. The ability to maintain it ensures that it will that it will perform as expected for many, many years to come. So designing with that maintainability in mind, ensuring the systems are easily accessible for maintenance, any of the valves, everything eventually unfortunately leaks and everything eventually will break. Ensuring that we can easily maintain those components is going to be critical. And finally, material selection. Ensuring that the materials are compatible to maximize the system life cycle is very critical to ensuring that you have a reliable system and one that's going to be, safe for the operators as well, that's not deteriorating to the point that it leaks or potentially has an explosive, atmosphere.
Right, so you mentioned leakage and maintenance there. So, what are some of the warning signs then that a gas distribution system might actually be underperforming, or if it's poorly specified, or just needs that little bit more close review?
Of course, the biggest thing is probably inconsistent gas availability. Sometimes at those point of use locations for the end user, sometimes it's there, sometimes maybe it isn't. 1 hour they're getting 15 psi, the next hour they're getting 5 psi. That's probably the number one symptom that we see of a gas distribution system that is either poorly specified or not working properly. That variance in pressure, something that we see all the time. If you have safety and relief valves in your system, which every good gas distribution system should, if those are frequently actuating, if they're frequently popping, that's also a sign that the gas distribution system is poorly specified, underperforming, and needs a closer review. And then finally, that gas consumption. If you're typically using 6 cylinders a week and now you're using 12 cylinders a week, that's definitely a sign that something's going wrong in your gas distribution system.
Great, thank you for that, Mike. And how can better specification or fabrication or testing or indeed post-installation support? I know how strong Swagelok are on that. How can all of that help to reduce the risk for teams that are responsible for gas distribution systems?
Absolutely. All of these work in harmony, right? Great specification, really good fabrication, a proper testing procedure, that support, they all work together in harmony to produce a really good gas distribution system. Proper specification ensures that compatibility. It ensures that the regulators are adequately sized so you get all of the gas where you need it to go. Redundancy ensures that the gas is available all the time. Maintainability ensures that your components are able to be swapped out and maintained. Skilled fabrication and testing ensures leak-tight performance. And that's the number one thing when you install a new system. The last thing you want to do is run around your facility chasing those leaks. So that skilled fabrication and a great testing plan ensures leak-tight performance upon installation. And finally, post-installation support provides system health insights, maintenance plans, spares availability, and really driving that technical partnership that allow the end user to achieve their desired business outcomes with their gas distribution systems.
Great, thank you for that. And I'd just like to add one more question in here. We're discussing gas distribution done right. So if you were speaking to a customer, what would be your one message to them on effectively how to make this gas distribution system done correctly?
Yeah, I think working with experts, right? No customer knows everything they need to about gas distribution. So pulling in folks that do, I think is going to be really critical. Starting with the design, a well thought out design, a well thought out maintenance plan. These are all so critical to the performance of gas distribution systems. And you can't wait until the last minute. The earlier you start thinking about these things, the earlier you start the specification process, that's going to allow for a more seamless installation, and it's going to ensure that that system from the second that you press the go button is operating as expected and you don't have any delays in bringing that system online.
Fantastic. Great insights, as always, from Swagelok and from you, Mike. Look forward to our next conversation, whether that be with you or one of your colleagues. But for now, Mike Strobel, thank you very much for your time.
Thanks, Tom. Thanks for having me. It was great.